Welcome back. For the next function, multiple letter count, we need to return an object with the key as the letter found and the value as the number of times that letter appeared. This one is a bit tricky, so before we dive into this problem, let's quickly review how we can access and set values in an object. Let's make an object called person. Now we can either use dot notation to set properties in this object, or we can use array bracket notation. So when do we use one or the other? We should always use dot notation unless we simply cannot. So when can we not use dot notation? The answer is when we don't know exactly what the key is going to be. When we need to evaluate an expression, which will determine the name of the key in the object, we need to use bracket notation. So going back to our problem, the object that we make will be different depending on the word we are counting letters for. So we need to use bracket notation to set keys and values in the object. If that's a little confusing, don't worry. It'll make more sense when we see a solution. To get started, we first need to make an empty object that will hold our values. Let's call this final obj. Now, just like the previous problem, we need to iterate over the string we are searching through. So let's make a loop to do that. Now at each character, we need to see if that letter is already a key in the object. If it's not, we need to set it as a key with a value of 1. Otherwise, we just increment the value for how many times it has been counted. So how do we do this? Back to bracket notation. We need to access a key in the object that has a value of whatever character we are at in the string. We reference the character we are at in the string by using str at index I. And to access a key with that value, we wrap str at index I inside of the final obj using array brackets. Once we're done looping, we can return the final object. For the next function, array manipulation, we need to do quite a bit. We have to handle multiple parameters, starting with the array, the command, which will either be remove or add, the position, which will be either the end or the beginning, and finally, a value if we're adding anything to the array. In this function, we'll use a series of nested conditions. Let's start by seeing if we need to remove something. If we need to remove, let's see if it's at the beginning or the end. If it's at the end, we'll return the result of the pop method, which returns to us the value removed from the array. Otherwise, we know it's at the beginning, so we'll return the result of the shift method, which returns to us the value removed from the array. Otherwise, if the command is add, we'll need to use either the push or unshift method. So first, let's see if the command is add, and check to see if the position is at the end. What's a bit tricky here is that this array manipulation needs to return the actual array when items are added. Unfortunately, the push and unshift method return the length of the array once a value is added. So we need to use push and unshift, but we need to return the array. So if the position is at the end, let's add the value passed to array manipulation to the end of the array using the push method. Otherwise, we'll use the unshift method. Regardless though, we need to return the array. If your answer looks a bit different, no worries. There are lots of ways to implement this function. For the next function is palindrome. There are many ways that we can solve this. If you do a bit of Googling, you may come across a very common solution which looks like this. Let's break down what this code is doing. First, we make the string lowercase to ignore any case sensitivity. Then we split the string into an array with each character as a value in the array. We then use the built-in reverse method to reverse the array and join the values back together as a string with no whitespace between the characters. Finally, we see if this reverse value is the same as the string we are checking. This is a valid solution, but let's see how else we could do this. Another option is to iterate through the string, and as we go through, see if the first character matches the last character. This is actually more efficient because once the characters are not the same, we can just exit the loop. Let's see what this looks like. Here we're seeing if the character we are at is not the same as the character in the string at the end minus 1, because strings and arrays are 0 indexed. And then we subtract the position we are at. So as we increment I, we move from the end back towards the beginning. If any of these values are not the same, we exit the function and loop and return false. Once we're done looping, we'll return true. In the next video, we'll build a very simple rock, paper, scissors game. See you there.